Good morning, everyone. Today we are going to discuss about torque measuring devices. So one of the absorption dynamometer, that is about Prony brake dynamometer. So in this class we are going to discuss about measurement of torque by using Prony brake dynamometer. So before going to measurement of the torque by using Prony brake dynamometer, first we are going to see what do you mean by torque. So after that we'll see the working and construction and advantage disadvantage of the Prony brake dynamometer. So first we are going to discuss about torque and power. So power is defined as the rate of doing work. So and it is equal to the product of force and linear velocity, or the product of the torque and angular velocity. So the measurement of power is involved the measurement of force. So the measurement of power involves the measurement of force or torque. So here the force or torque is measured with the help of dynamometer and the speed of the tachometer. So here the torque is nothing but twisting moment of the shaft or turning moment. So torque is nothing but twisting moment of the shaft. So here the torque equation T by J equal to G theta by L and tau by R. So where the T equal to maximum twisting torque, G equal to modulus of rigidity, J equal to polar moment of inertia. So twisting angle, theta equal to twisting angle, where L equal to length of the shaft, and tau equal to shear stress and R equal to shear radius. So this is the torque equation T by J equal to G theta by L equal to tau by R. So here the T equal to maximum twisting torque. So the torque is nothing but twisting moment of the shaft. If you know the torque, then you have to find easily the power. Power equal to P equal to 2 pi nt by 60. So where P equal to power, brake power in kilowatts, T equal to torque, the units of the torque equal to Newton meters. So that means the force into a distance. The torque equal to the units of the torque equal to Newton meter. So where n equal to rotational speed in the RPM. So the torque may be measured in terms of reaction of force and arm length or angular twist. So here we are going to measure the torque. So in terms of force, that means weight, and length, arm length. So one of the torque measuring devices. Now in this class we are going to focus one of the torque measuring devices. So that is about absorption dynamometer. So measurement of torque by using absorption dynamometer. In the absorption dynamometer we are going to see the Prony brake dynamometer. Prony brake dynamometer. So now we'll see the construction and working of the Prony brake dynamometer. So you can observe this figure. So that it will be consists of, so this Prony brake dynamometer used to measure the power of rotating shaft. So here we have a shaft, you can observe in this diagram. So this Prony brake dynamometer used to measure the power of rotating shaft. So it consists mainly, so two weights, two wooden blocks. So here we have two wooden blocks. These are the two wooden blocks. And counterweights. So counterweights and springs and nut assembly will be there. Then we have a shaft and pulley arrangement. So here we have a shaft and pulley arrangement. So here mainly we have a shaft. After that we have a pulley. Shaft and pulley is there, and two wooden blocks are there. So here at the right side we have a weight mechanism will be there. So lever and a weight mechanism will be there. So here we are going to measure the torque and power. So here when the shaft is rotating, the shaft is rotating, so then the pulley also rotating. So here we have a shaft and pulley will be there. So shaft, or the shaft we have a pulley is there. So it consists of shaft. After a pulley is attached to the shaft. So one pulley is attached to the shaft. So here you can observe in this diagram. So these wooden blocks which are just above the pulley. So here it consists of a pulley. Then shaft is attached to that pulley. So it consists of a pulley is attached to the shaft. So here we have a shaft. After that shaft, we have a pulley is there. Then we have a two wooden blocks. Two wooden blocks are just above the pulley. These two wooden blocks are just above the pulley. Then we have a nuts and bolts mechanism also there. Nuts and bolt mechanism adjust the gap between wooden blocks and the pulley here. So you can observe in this diagram, just nuts and bolt mechanism also there. Adjust the gap between. So adjusting the gap between. So here the adjusting the gap between the wooden block and pulleys, or we can call it as a drum. So here nuts mechanism will be adjusting the gap between wooden block and pulley. So then we have a one more attachment, that is about the length of the lever. Length of the lever. So that is the length of the lever. So the length of the lever means from the center of the shaft. So this is the from the center of the shaft to attached weight. So this we call it as a L. We call it as a length of the lever. So from the center of the shaft to load here, where the load here. So the load is attached to here. That means weight is attached to here. So that we call it as a length of the lever. So here the torque equal to force into L. F into L equal to length of the lever. So then we have a stops also provided. Stops S1 and S2 will be there. So the stops will be provided to stop. What is the purpose of stops? So something will be stopping. So it will be restricting the motion of the lever from going extreme position or extreme conditions. So these stops S1 and S2 stops are provided to stop or restrict the motion of lever from going extreme condition. So that it may be going up or going down. So it will be restricting extreme position or extreme condition of the lever. So it means the lever so does not move extreme up or does not move down extreme condition in downward direction. So it will be restricting the extreme condition of the lever. So that's why we are using S1 and S2 levers. Then we have a counterweight. So the counterweight will be if any unwanted vibrations of the lever, so that will be avoiding by counterweight mechanism. So this counterweight to avoid the vibrations of the lever. So these are the construction of the Prony brake dynamometer. So consists of counterweight around two wooden blocks, nuts and spring mechanism and lever, and we have a shaft and pulley mechanism. Right? So this L equal to center of the shaft to center of the shaft to where the attached weight. Center of the shaft to the attached weight we call it as a L, length of the shaft, that we denoted by L, length of the shaft from the center of the shaft to attached weight. So this is the construction of the Prony brake dynamometer. So now we'll see working of the dynamometer, how the dynamometer will works, Prony brake dynamometer will works. So here so it will be measuring the power by using Prony brake dynamometer. So when the shaft starts rotating, the pulley also rotating. So here when the shaft is rotating, the pulley also rotating. When the shaft is rotating, the pulley also rotating. So whenever we are increasing this weight, whenever we go on increasing the weight, the wooden blocks are start coming to close to each other. These wooden blocks are coming to close each other. So whenever we are going to run the machine, or when we are starting the shaft, whenever the shaft starts rotating, the pulley also rotating. So whenever the starting the machine, so when we go on increasing the weight, so these wooden blocks are coming close to each other. The wooden blocks are start to coming close to each other. So when the weight loads are reaching its maximum limit, when the weight is reaching its maximum limit, at that time pulley stops the rotation of the shaft. So whenever we are increasing the weight, whenever the weight is reaching the maximum limit, at the time pulley stops the rotation of the shaft. pulley stop the rotation of the shaft. So that means when the shaft rotation stops, so at that time we'll find the torque. So the torque equal to force into distance. The torque equal to force into distance. That time we call it torque that equal to force into distance. Torque equal to force into distance. So I'm repeating. So when we go on increasing the weights, so when we are go on increasing the weight, the wooden blocks are start to coming closing each other. These two wooden blocks are coming to close each other. So when the weight is reaching its maximum limit, at the time pulley stops the rotation of the shaft. At the time that pulley stops the rotation of the shaft. So when the shaft rotation is stops, so then we'll find the torque. So the torque equal to weight W, that equal to W equal to weight, and L equal to length of the lever. So for finding the torque, that weight into length. So length means length of the lever. Already we discussed it. Center of the shaft to reaching the weights. So that we call it as a length of the lever. So where torque equal to force into radius or force into length of the lever. That we call it as a length of the lever. So for finding the torque, we are going to use how much of load will be used. So for recording the weights and distance, easily we find the torque equal to force into distance. So in this way we are going to find the torque by using brake dynamometer. These are the notations. So after finding the torque, we will easily find the power. P equal to 2 pi nt by 60 kilowatts. 2 pi nt 60,000, that means 2 pi n, and where torque equal to W into L, where torque equal to W into L. So here the W equal to applied load at the end of the arm. So this W equal to applied load at the end of the arm. Then L equal to length of the arm. So length of the arm is nothing but center of the shaft to attached weight. So this is about L. So W equal to applied load at the end of the arm, and where L equal to length of the arm, that length of the arm in between the center of the shaft to where the load is attached. So this length for finding the L and for recording the L and W, for easily we are going to find the P value and T value, torque and power. So where P equal to 2 pi nt by 60,000, where T equal to W into L, that we will be finding an torque that will be Newton meters. So in this way we are going to find the torque by using Prony brake dynamometer. So in this way we are going to find the torque by using Prony brake dynamometer. So now we are going to see the advantages and So now we are going to see the advantage and disadvantage of Prony brake dynamometer. So the brake dynamometer brake dynamometer in simple in construction, less in cost, suitable for measurement of small power. It will be suitable for measurement of small power. So even though some advantage, it has some disadvantages. It will not suitable for large power. So this cooling system is required. Shaft is not uniform. So this dynamometer is subject to severe oscillations. Shaft is not uniform, dynamometer is subjected to severe oscillations. So these are the advantages and disadvantages of Prony brake dynamometer. So I hope you are understanding the concept of construction and working of the Prony brake dynamometer. Thank you.